Today we're going to talk about something called compound probability. A compound probability or a compound event is just more than one event happening. So two or more events happening kind of simultaneously. So when we're talking about compound events, we have two different types. We have independent and dependent. So independent means that one outcome doesn't necessarily affect the next outcome. Dependent means the second outcome depends on what happens with the first one. So for instance, if you're talking about like a deck of cards and you pull out a 3 of hearts. Okay, well, if I don't put that card back in the deck, then my next pull of a card will depend on what happened in my first one, right? Because there's no chance of me pulling a 3 of hearts again. Okay, so that's what dependent means. So we're just going to quickly look at three examples here just to decide if they're dependent or independent. So first one, choose a number tile from 12 tiles, then spin a spinner. So the number tiles have no impact on the spinner, right? So these are independent events. The next one says, pick one card from a set of 15 sequentially numbered cards, then without replacing the card, pick another. Okay, so this is a dependent. Okay, so it depends on what number I picked first if it's going to happen again, right? So if I pulled a 5 first, there's no chance I'm going to pull a 5 the second time. Last one, you roll the dice, then you flip a coin. Again, just like the first one, the dice has nothing to do with the coin. So these are independent. When we have independent events, we talk about this and or. So we're going to first look at and. Okay, so independent events, the way it's written is like this. The probability of A and B. Okay, the probability of both of those things happening is the probability of A times the probability of B. Okay, we're just multiplying those events together. So the first one says a desk drawer containing 5 red pens, 6 blue pens, 3 black pens, 24 silver paper clips, and 16 white paper clips. If you select a pen and a paper clip from the drawer without looking, what's the probability you select a blue pen and a white paper clip? All right, so let's look at the blue pen first. So out of my pens, I have a total of, 14 pens, okay? A total of 14, and there are 6 blue pens. So the probability of pulling a blue pen is 6 out of 14. Now this says and, right? So I'm going to multiply a white paper clip. All right, so my paper clips, I have 24 silver and 16 white. Okay, so that's a total of 40 different paper clips. The white ones, there's only 16 of those. Okay, so if I multiply those together, 6 times 16 gives me 96. 14 times 40 gives me 560. You can simplify that or put it to decimal. A lot of times once you start getting to like independent events and start multiplying stuff together, they typically do put it into decimal. Either way, though, is technically correct. So 0.17, 0.1714, however you'd like to round that. I would do at least 2 decimal places. All right, next example. You roll a standard number cube and spin the spinner below. What's the probability that you roll a number less than 3 and a spinner lands on a vowel? Okay, so let's deal with the number cube. Okay, so that's 1 through 6. What's the probability that you roll a number less than 3? Well, that's just 1 and 2. 1 and 2 are the only numbers less than 3. So that's 2 out of 6 possibilities we can get a number less than 3. Now, if we look at the spinner, I know your copies came out a little bit dark, but there's really only one vowel here. That's U. Okay, so only 1 and 4 is our probability there. So 2 times 1 is 2. 6 times 4 is 24. Again, you can simplify that or write it as a decimal.
Where you go?
The next topic we're going to talk about are called mutually exclusive events. So these are events that cannot possibly happen at the same time. So for instance, like if you're spinning a spinner and it has, red, yellow, blue, and green, it can't land on a blue and a green at the same time. Okay? Or my example here says you cannot roll a 2 and a 5 on a number cube at the same time. Okay, so those events are called mutually exclusive. It's just not possible. So mutually exclusive events are typically ORs. Okay, they usually call them ORs. So the probability of both of them happening at the same time is 0 because it's not possible for it to happen. Right? Remember how on Friday we talked about like 0 means it's impossible, a probability of 1 means it's guaranteed to happen. Okay, so this is impossible. So an or statement typically means that you're going to add the probability of the two events together. So here's an example. It says student athletes at a local high school may participate in only one sport each season. Okay, so meaning these things are going to be mutually exclusive. They can't be in both. Okay, so during the winter season, 28% of the student athletes play basketball and 24% are on the swim team. What's the probability that a randomly selected student athlete plays basketball or is on the swim team? All right, so keep in mind 28% we can really write as 0.28 and 24% we can really write as 0.24. All right, so this is an or. So what's the probability of, where are we? I'm sorry, basketball or probability of, what was the other one? I'm sorry, swim team. Okay, because it's an or, we're going to add them together. So the probability of basketball is 0.28 plus the probability of swim is going to be 0.24. So when I add those together, you should have 0.52. Okay, at that same high school then, in the spring season, 15% of the athletes play baseball and 23% are on the track team. What's the probability of an athlete either playing baseball or being on the track team? Okay, so 0.15 for baseball, sorry. And then we need to add together the track team. So 0.15 plus 0.23 gives us a total of 0.38. Okay, so most of that probably is not a surprise to you. The and the or, sometimes people forget whether you're multiplying or adding. The and is multiplying, or is typically adding. There's a little bit of an exception though. These are called overlapping events. So basically what happens is you're counting the number of times something's happening, but you have to be careful because sometimes you can double count an event. So overlapping events is when you have that possible double counting that's going to happen. Okay, so here's the formula. Okay, this formula is actually on the AIR test, but it's really common sense as well once you start thinking about what's happening. So the probability of A or B, so it's an or problem. However, you have to think about sometimes you have events that overlap. So it says take the probability of A, add the probability of B, but we need to take the probability of A and B away from that. That's where it's counted twice. Okay, it'd be kind of like counting, if I counted the number of juniors in our class and I counted the number of girls, there's potential that I would have junior girls and I counted them in 2 different groups, but I counted them twice when there's really only one person. Okay, so an example, on a standard number cube, so on a dice, the event of rolling an even number and a multiple, sorry, there should be an and in there, and a multiple of 3 overlap because the roll of 6. So rolling an even number on a dice, that could be 2, 4, or 6. Rolling and, what did it say, even, a multiple of 3, multiple of 3, that's 3 and 6. So if I counted 5, I wouldn't be completely wrong, but the problem is the 6 is actually being counted twice, and it's just the same number. Okay, so we have to be careful of that overlap. An example. It says, what's the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube? Okay, so probability of rolling an even. Okay, so that's going to be a 2, 4, and a 6. The probability of rolling a multiple of 3, that's going to be a 3 and a 6. So probability of even is going to be 3 out of 6 numbers are even. Plus, because it's an or, probability of multiple of 3, that's 2 out of 6. However, I have one overlap, right? There's one that fall into both categories. So the probability of A and B is 1 out of 6. There's one overlap, so I need to subtract 1/6. That gives me a total of 4/6, or you can write that as a decimal, so 0.67, either way. A and B, oops. All right, now, next one. What's the probability of rolling either an odd number or a number less than 4 when rolling a standard number cube? So probability of rolling an odd number. Okay, so the probability of odd, our odd numbers are going to be 1, 3, and 5 that are on a number cube. Okay, numbers less than 3. So probability of being less than 3. No, I'm sorry, less than 4. Sorry, less than 4. Those are going to be 1, 2, and 3. Those are all the numbers less than 4. So the probability of odd, that's 3 out of 6. The probability of it being less than 4, that's going to be 3 out of 6. Okay, but we got to figure out how many doubled up. So the probability of it being odd and less than 4, we have 2 of them, right? We have a 1 and we have a 3 that's doubled up. That's 2 out of 6. So I have to take away those 2 possibilities. That gives me 4/6. So 3 plus 3 minus 2 gives me 4/6, which is 0.67. All right, so that's 0.67. I didn't mean to draw the repeating symbol there. All right, so your homework is just going to be practicing this. Sometimes it's odd, or sometimes it's an or where you're going to add. Sometimes it's an and where you're going to be multiplying. Sometimes you have to think about those overlapping events, and I kind of mixed them together a little bit, so you have to stop and think, is it possible that I'm double counting?